Hello everyone, welcome to our mathematics class once again. In our previous video, we have discussed about the basic concepts of polynomials. Now in this video, we will try to learn more on polynomials, okay? If those who have not gone through the previous video, you were asked to go through those videos so as to understand the polynomial in a better way. In our previous video, let us continue from here. In our previous video, we have discussed up to degree of polynomials, right? We took some examples. Look at 6x cubed plus 7x square minus 8x plus 3 is what is the degree of this polynomial? Degree in case of a linear polynomial in one, or in case of a polynomial in one variable, degree is the power on the maximum power or the highest power on the variable, right? And here in this video, in this polynomial, the highest power on the variable is found to be 3. Therefore, the degree of this polynomial is 3. And when the degree of a polynomial is 3, then such type of polynomials are known as cubic polynomial. The second example, if you look, then it will be 5x square minus 7x plus 11. So this is also a linear polynomial in one variable, and the degree of this polynomial is the highest power on the variable. What is the highest power that can be seen in this polynomial? That is 2. So highest power on variable x is 2. Therefore, in this case, the degree of the polynomial is 2. And when the degree of a polynomial is 2, then such type of polynomials are known as quadratic polynomial. Then similar way, in this case, this is a polynomial in one variable. The variable is x here, and here is the maximum power 1. And when the polynomial has got the higher degree 1, that means highest power 1, then such type of polynomials are known as linear polynomial. Clear? So we have discussed in the previous video. Then the fourth example I have taken as 7y to the power 4 plus 8y cubed minus 5y square minus 6y plus 7. Here this is also a linear this is a polynomial in one variable. The variable is y only. And what is the degree of this polynomial? The highest power on the variable y is 4. Therefore, the degree of this polynomial is 4. And when the degree of a polynomial is 4, such type of polynomials are known as biquadratic polynomial. So this was our previous discussion. Now here in this class, in this video class, we are also going to discuss more and more related to polynomial. All right, so now today we are going to discuss types of the polynomial on the basis of the number of terms. Okay, the polynomial having one term, polynomial having two terms, polynomial having three terms, etc. This kind of things we are going to learn in this class. So get ready. Be ready with your notebook, and you just follow the class. Whenever you are writing or going through the class, you just copy the things, necessary informations, you just note it down. All right. Well, let us understand now the polynomials on the basis of number of terms. A number of terms in polynomial. Number of terms in polynomials. All right. On the basis of the number of terms, polynomials are further divided into different classes, different parts. Those polynomials having only one term are known as monomial. Mono means one. Okay, monomials means the polynomials having only one terms are known as monomial. For example, monomial. What are monomials? I said the polynomials having only one term are known as monomial. All right. You can write the definition also. It may come in the examination. Define monomial with an example. All right. Then sometimes it may be in the examination. Define, give an example of linear monomial. Give an example of quadratic monomial. Give an example of cubic monomial. Give an example of biquadratic monomial. All right. So this kind of questions may be there in the examination. So monomial means number of terms. If there is only one term in the polynomial, then such polynomials are known as monomial. Again, linear monomial means those monomials whose degree is 1, those monomials whose degree is 1 are known as linear monomial. Then quadratic monomials are those monomials whose degree is, or that means maximum power is 2. Then such type of monomials are known as quadratic monomials. Then cubic monomials, those monomials whose degree is 3 are known as cubic monomials. Similarly, biquadratic monomials, those monomials whose degree is 4 are known as biquadratic monomials. So you have to be clear with the terms. Clear? So monomials, as I said, that those polynomials which has only one term, having only one term, are known as monomial. So for example, it may be a single number, this can be a monomial. Or suppose 7x, this can also be a monomial. Suppose 3y, this is one more monomial. Suppose 2x square, this can be a monomial. Suppose 4z cube, this can also be a monomial. So in this way we can write infinite numbers of monomials, right? Doesn't matter what is the power on the monomial. If there is no power, if there is no power means 1, power is 1, then this is called linear monomial. Monomial it is because there is only one term, that's why it's a monomial. Alright, and linear because its highest power is 1, that's why it's a linear monomial. Since there is only one term, so it is monomial, and highest power on the variable is 1, so it is linear monomial. Clear? So this is also a linear monomial since it has only one term, that is thrice y. This will be a single term. Then this kind of polynomials are known as monomials, and it is also linear because highest power on the variable is 1. That's why it is also a linear monomial. Similarly, this is a monomial. Of course it is a monomial, but is it a linear monomial? Of course not. It is not a linear monomial. It is a quadratic monomial since the highest power on the variable is 2. So highest power on the variable is 2, that is it is degree is 2, and since degree is 2, it's a quadratic, and since it has only one term, that is 2x square, so this is a quadratic monomial. This is cubic monomial. All right, similarly we can write biquadratic monomial. Biquadratic monomial, can you give an example of your own? Yes, you can, because there are infinite numbers of infinite numbers of such monomials. Suppose 5p to the power 4. This is a biquadratic monomial. Biquadratic because the degree of this polynomial is 4. Monomial because there is only one term, that is 5p to the power 4. Alright, so monomial, hope you have understood the monomial. Monomials means those polynomials which has only one term are known as monomial. Now, what will be the polynomial if there is only two terms? There are two terms. If there are two terms, then such type of polynomials are known as binomial. What? Binomial. The polynomials having two terms are known as binomials. Alright? Binomials. B-I-N-O-M-I-A-L. Binomial. What are binomials? Those polynomials which have only two terms. Only two terms. Alright, monomial only one term, binomial two terms. Clear? Those polynomials having two terms are known as binomial. Suppose 3x square plus 2. So how many terms can you see in this polynomial? There are two terms. One is 3x square and the other is 2. Alright, since there are two terms, such type of polynomials are known as binomial. There are many more examples, so we can write suppose 4x plus 1. It can be also it can be a binomial because there are only two terms. Then 5y cube plus 3x square. Alright, this is also a binomial. This is also a binomial, yes, of course. Then suppose 6z square or 6z square minus 2z. This is also a binomial. So any polynomial which have only two terms, if the polynomial carry only two terms, then such type of polynomials are known as binomials. Is it cleared? Binomials means those polynomials having only two terms are known as binomials, right? Now this is a binomial, this is a binomial, this is a binomial, this is a binomial because they have only two terms in each. Now what type of binomial is this? This is a quadratic binomial. Why it is a quadratic binomial? Because the degree of this binomial is 2. Since degree is 2, highest power in the variable is 2, therefore it is a quadratic binomial. Then this is linear binomial. Linear binomial means since the power on the variable is 1, therefore it is a linear binomial. Then it is, yes, it is a cubic binomial. Yes, you have to see highest power on the variable. Alright, highest power on the variable here also, but in case of a polynomial in more than one variables, how to find out the degree, there is another method. So we will learn soon after this. Alright, soon after this means on the best polynomials or number of terms in a polynomial. After learning this one, we will learn the degree, how to find out, how to determine the degree of those polynomials which carries more than 2 or more than 1 variables. Because in the previous video we have discussed, or today also in the beginning, in this class also in the very beginning, we have discussed the degree of the polynomial having only one term, right? But the polynomials can carry more than one terms also. In that case, what will be the degree, or how the degrees of those polynomials are determined, we will discuss soon after this. So binomial means there are two terms, one is 3x square and other is 2, so it is a binomial. This is also binomial, there are two terms, one is 4x, other is 1, so it is a binomial. This is also binomial because there are two terms, one is 5y to the y cube plus 3x square. This is also a binomial because there are two terms, there is 6z square minus 2z. Alright, so all these are binomial. This is a quadratic binomial because degree is 2. This is a linear binomial because degree is 1. This is a cubic binomial because maximum power on the variable is 3. This is a quadratic binomial because the maximum power or the degree of the variable, degree of this polynomial is 2. That's why quadratic binomial. Hope you have understood binomials. Binomials means number of terms. If there are only two terms, then such type of polynomials are known as binomials. And binomials can be linear, binomials can be quadratic, binomials can be cubic, binomials can be biquadratic, whatever it can be depending on the power on the variable. Clear? So hope you have understood the binomials. Now after binomial, let us learn another type of polynomials on the basis of the number of terms. If a polynomial carry 3 terms in it, then such type of polynomials are known as trinomial. What? Trinomial. Tri means 3. Mono means 1, bi means 2, and tri means 3. If a polynomial has only 3 terms, or if a polynomial containing 3 terms, 3 non-zero terms are called trinomial. Alright, trinomial. T-R-I-N-O-M-I-A-L. Trinomial. Trinomial, 3 terms, a polynomial containing 3 terms. Suppose 3x cube plus 2x square plus x. This is a polynomial having 3 terms. Look at, one is this, other is this, and this is the third one. Then suppose 4y square minus 2y plus 3. This is also a polynomial having 3 terms, so it is a trinomial. And suppose we can have another one, suppose 4y minus y plus, sorry, minus x we can write, okay, minus x plus 3, say. This is also a trinomial. So trinomials, if a polynomial carry only 3 terms, then such type of polynomials are known as trinomial. Here in this case you can see there are 3 terms. One is this, the second is this, and the third is this. In all these polynomials, this is one, then the third one. In all these polynomials you can see that there are 3 terms in each. Now this is a cubic, trinomial, this is trinomial, this is also trinomial. Now what type of trinomial is this? It's a trinomial of highest power 3, so it will be a cubic trinomial. What? Cubic trinomial. Since the degree of this polynomial is 3, so it is a cubic, and since there are 3 terms, so it is trinomial. So cubic and trinomial. So cubic trinomial. This is trinomial, and what is the degree of this polynomial? Degree means highest power on this variable, on the variable of this polynomial is 2. So this is a trinomial since there are 3 terms, and this is highest degree of this polynomial is 2. Therefore it is quadratic trinomial. Then this is linear trinomial. It is because the highest power on the variable is 1 and there are 3 terms. So it is 3 terms. Because of having 3 terms, this is a trinomial, and highest power on the variable is 1, therefore it is linear. So linear trinomial. Okay, so can be given in the examination that give an example of quadratic trinomial, give an example of, write an example of cubic trinomial. So trinomials mean number of terms. You have to keep in mind that if the polynomial carries only 3 terms, then such type of polynomials are known as trinomials. And if the degree is 2, then it is quadratic trinomial. If the degree is 3, then cubic trinomial. If the degree is 1, then it is linear trinomial. So hope you have understood up to here the trinomial. Monomial, we have discussed a monomial, binomial, trinomial, and so it will go on increase. If there are 4 terms, then again the name will be changed. But for class 9 students or for class 9 standards, you have to learn up to here only. Then constant polynomial. What are known as constant polynomials? Let us understand constant polynomial. See, polynomial is a very simple concept, very easy concept, but the thing is that you have to understand the basics. Okay, if your basic is clear, then polynomial is very simple thing. If basics are not cleared, then it will create a problem. It may create problem, and it will certainly create problem. All right, so you are asked to clarify your basics regarding polynomials. Clear? Now let us understand the constant polynomials. You can write constant polynomial, its definition also. A polynomial containing one term only, consisting of a constant, is called constant polynomial. A polynomial containing only one term and the term is constant itself, then such type of polynomials are known as constant polynomials. Okay, constant polynomial. Constant polynomial. If a polynomial contains only one term and the term itself is a constant, then such type of polynomials are known as constant polynomial. All right. Suppose I have 5. It's a constant term, right? It's a constant term. Only one term is there, and it is a constant term. That's therefore it is a constant polynomial. What is the degree of the constant polynomial? Degree of the constant polynomial is 0. Remember, what is the degree of a constant polynomial? Non-zero constant polynomial. The degree of a non-zero constant polynomial is 0. Why it is so? So degree means we are observing the power on the variable, and there is no such variables. Since there is no such variables, we can imagine one variable. Say for example, x is there with the power 0, right? With the power 0, because x to the power 0 or any variable to the power 0 is always equals to 1. So writing x to the power 0 means it indicates 1. So 5 into 1 is ultimately 5. Its value is 5. Alright, so in this way we can write that what is constant polynomial? A polynomial containing only one term and the term itself is a constant, are called constant polynomial. And what is the degree of a constant polynomial? Our degree of the non-zero constant polynomial is 0. Remember, degree of a non-zero constant polynomial is 0. Suppose one more example we are considering, that is 7. 7 is also a constant polynomial, right? What is the degree of this polynomial? You can imagine any variable here, any variable. It doesn't mean that you have to imagine only x always. You can imagine y, you can imagine of your own variable, that is a, b, c, d, whatever you can consider, whatever you can imagine. Suppose I am imagining here y, and what is power on y here? Since there is no power, so I am putting here 0. Since y to the power 0 means 1, and 7 into 1, its value remains 7. So since it's a constant, its value is constant, and the power on the variable is 0, though, so we can say that it is a constant polynomial. And what is the degree of this polynomial? Since for the degree we need to see the power on the variable only, not on the constant term, right? So degree of this variable is 0. So non-zero constant polynomial, its degree is 0. So constant polynomial, what is the degree of a non-zero constant polynomial? This may be a question, you can note it down. what is the degree of a non-zero constant polynomial? The answer will be 0. The non-zero constant polynomial, its degree is 0. Then one more term comes sometimes, that is called zero polynomial. Zero polynomial. Remember, constant polynomial, we have already understood that if a polynomial contains only one term and the term itself is a constant, then such type of polynomials are known as constant polynomial. Then one more term comes, that is called zero polynomial. What is zero polynomial? Okay, you can write the definition of zero polynomial. All right, a polynomial containing one term only. Sorry, a polynomial consisting one term, mainly 0 or namely 0, is called a zero polynomial. Once again, a polynomial consisting of one term, namely 0 only, is called a zero polynomial. Okay, zero polynomial. That means if a polynomial contains only one term, the term is 0 itself. Understood what I said? If a polynomial contains only one term, the term is 0 itself. Term is 0 itself. Then it is called zero polynomial. And what is the degree on the variable? Degree of this polynomial? See, it is not defined. Why it is not defined? See, degree is already observed, always observed on the variable. Since there is no variable, we can imagine one variable. Suppose what we are going to imagine, suppose k. We are imagining k. This is not okay, okay? This is 0, 0, and our 0 is not looking like 0, right? It's look like O. Okay, then zero polynomial. See, if a polynomial contains only one term, that is 0 itself. If a polynomial contains only one term, that is 0 itself, is called zero polynomial. What is the degree of a zero polynomial? What I said, degree of the zero polynomial is not defined. See, degree is always observed on the power on the variable, right? What is the variable here? Since there is no variable added, so we can imagine one variable. What I said in the previous case, that was k. Suppose k is a variable in this case. Say, let us understand. What is the power on the k? It may be anything. Since this is 0, 0 is multiplied with the variable, it will give ultimately 0, and whatever power it can be, it can have power 100, it can have power 1000, it can have power 5 lakhs, 1 lakh, 2 lakhs, whatever it can have. All right, so its power is not defined. Clear? Degree is not defined. What is a zero polynomial? If a polynomial contains only one term and what the term is, the term itself is 0. If a polynomial contains only one term and the term itself is 0, then such type of polynomials are known as zero polynomial. And degree of a zero polynomial is not defined, as you have observed here. Since 0 is a zero polynomial itself and there is no variable attached with it, so we have considered that k is attached with it. So 0 into anything is always 0. Its value will still remain 0, but power on the variable k can be considered as 100, can be considered as 200, 300, 500, 400, whatever it can be, even 1000 we can consider. It can vary its power, it can have varied power. That's why it's not defined. It has no fixed power on the variable, right? So what is a zero polynomial? Hope you have understood. A polynomial containing only one term and the term itself is 0 is called a zero polynomial. All right. And what is the degree of the zero polynomial? It is not defined because it can have any degree, it can have any value of the power on the variable, right? That's why the degree of a zero polynomial is not defined. Up to here we have understood the different types of polynomials: monomial, binomial, trinomial, then linear, quadratic, cubic, biquadratic we have discussed. After that, constant polynomial we have discussed, and zero polynomial. These are the various terms related to the polynomial. Now, as I told you that after learning these, we will learn how to find out the degree of those polynomials carrying more than one variables. All right, so get ready to learn that one. Up to here it is over. You can note it down degree of a polynomial in two or more variables. You can write it down, degree of a polynomial in two or more variables. Degree of a polynomial in two or more variables. You can write it down. Write the headline, degree of a polynomial in two or more than two variables. How we have written, then you write, in case of a polynomial in more than one variable, in case of a polynomial in more than one variable, the sum of the powers of the variable in each term is taken up, and the highest sum so obtained is called the degree of the polynomial. Suppose we have an example, 7x cube minus 5x square y square, then plus 3xy plus 6y plus 8. This is one example. One more example let us consider, that is 4x square y cube minus 5xy square plus 7 minus root over 2 x to the power 4. Alright, one more example let us consider, that is number 3, 6x to the power 4 minus 7x cube plus 8x square minus 9x plus 10. So one more example let us consider, that is 11y to the power 4x square minus 6x cube y plus 7xy minus 3x minus 2y. We have 4 examples with us. Now let us understand how to find out the degree of this polynomial, how to determine the degree of these polynomials. Look at, in this case, this is a polynomial but there are two variables. So this is a polynomial in two variables, and in this case, in the case of polynomials in two variables or more than one variable, degree is determined by summing up the powers, okay, in each term. Clear? So in this case, what can you see? The power, maximum power is 3. Alright, what can you see here? The maximum power, we need to sum up the powers, that is 2 plus 2. Its power, maximum power will be 2 plus 2, that is 4. Alright, here in this case the maximum power will be, nothing is there, that means 1 1. 1 plus 1 is 2. Here the power is 1. So what can you see? What is the highest power? Here it is 3. If you sum up these two powers, 2, 2, then it will be 4. Alright, this is 3, this is 4. This is 1 plus 1 is 2. Then it is 1 only. So highest power you have obtained, that is 4. Alright, because you have to sum up the powers on this variable. This is 2, this is 2. Thus 2 plus 2 is 4. So degree of this polynomial will be 4. What is the degree of this polynomial? That is 4. Degree is 4. In this case, the degree is 4. What is the degree of this variable, this polynomial? This is also a polynomial in two variables, because there are two variables, that is, one is x and the other is y. So degree of two variables, polynomial having degree 2. Polynomials having two variables. Now how to find out the degree? We have to sum up the power on the variables in each terms, and the maximum power will be the degree of this polynomial. Here in this case, what is the maximum power? What can you obtain after summing up? There is 2 plus 3 is 5, so maximum will be 5. Here there is no power, that means 1 plus 2 is 3, so maximum is 3. Here maximum is 5, here maximum is 3. Here there is no power, that is 0. Here there is 4, so maximum power so obtained is 5 in this case, right? What is the degree then? Okay, here also the degree will be 5. In this case, what type of polynomial is this? Look at, this is a polynomial in only one variable. The variable is x only. There is no other variables except x, right? So this is a polynomial in one variable only. So in this case, what to see? The maximum power on the variable. What is the maximum power on the variable? You can see here. That is 4. So what is the degree then? That definitely it is 4. Degree will be 4 in this case. What type of polynomial is this? This is a polynomial in two variables. Alright, polynomial in two variables. What are the two variables? One is y and the other is x. So there are two variables, x and y. Now in this case, what to do? We need to sum up the power on the variables. Clear? And the maximum power so obtained will be the degree of this polynomial. Clear? So what is the maximum power so obtained will be 4 plus 2, that is 6. Here it is 3 plus 1, that is 4. There is 1, 2. So 6 is the maximum power. Alright, 6 is the maximum power. What will be the degree then? Degree of this variable, degree of this polynomial will be 6. So hope you have understood. We have learned how to determine the degree of a polynomial having only one variable, and we have already learned till just now that how to find out the degree of those polynomials having more than one variables. If a polynomial carry more than one variables, then degree of such polynomials are obtained by summing up the power on the variable. Clear? And the maximum power so obtained will be the degree of this polynomial. Then we have learned different types of polynomials, and in class 9th standard this is enough to learn. Now we have to learn what is the zero of a polynomial, value of a polynomial and zero of a polynomial. We will discuss in our class. Yeah, after learning the basic of polynomials, let us understand now the questions given in the exercise 2.1 of class 9. Exercise 2.1, you can see which of the expressions are polynomials in which in one variable and which are not. State reasons for your answers. For your answer. Okay, this is the first one, number 1. That is 4x square minus 3x plus 7. Is it a polynomial in one variable? Of course, it's a polynomial in one variable. So it is a polynomial in one variable since the variable is only x, and power on the variable is the, it is a whole number. Power on the variable is a whole number. It's a polynomial because power on the variable is a whole number. It is a polynomial in only one variable. That variable is only x. Then second one is y square plus root over 2. Is it a polynomial in one variable? Definitely it is a polynomial in one variable. Why it is a polynomial? Since the power on the variable is a whole number, and only one variable since the variable is y only. So it's a polynomial in one variable. This is also a polynomial. Then third one is 3 into root over t plus t root over 2. Is it a polynomial? Okay, if we reduce it in the simpler form, then it will be, I'm writing this side, alright, 3 into t to the power, if you remove the square root, it will be t to the power half. Clear? Plus t root over 2. So look at here, power on t is half, it's a fraction. Clear? Since a variable carry a power which is not a whole number, that is a fraction, therefore it is not a polynomial. Okay, see, polynomial carries only whole number as the power on the variable, right? If the variable contain power which is not a whole number, it's a fraction, decimal number or any negative number, then it cannot be a polynomial. Remember, we have discussed in the previous class also. So can it be a polynomial? Of course not, it cannot be a polynomial. Why it cannot be a polynomial? Then what is the reason? The reason is one of the variable, that is t, contain a power that is half, t to the power half. Alright, since it contains a power which is not a whole number, therefore it is not a polynomial. Cleared? Now the third one is done. After doing the third one, the fourth one will be y plus 2 by y. If you reduce it into its smaller or simpler form, then it will be y plus 2 into y to the power minus 1. Can we write it as minus 1? Yes, 1 by y is y to the power minus 1, right? Can it be a polynomial? Of course it cannot be a polynomial. Why it cannot be a polynomial then? What is the reason? The reason is one of the variables contain a negative power. Since it contains a negative power, it cannot be a polynomial. See, to be a polynomial, an expression must contain a power on the variable which must be a whole number. Clear? Now this cannot be a polynomial. After that, okay, instead of this, can it be a polynomial? If I ask you y plus y by 2, can it be a polynomial? Definitely it can be a polynomial, but the same y plus 2 by y, it cannot be a polynomial. It is not a polynomial, it is a polynomial. Look at, are you confused here? The first one is a polynomial, but the second one is not a polynomial, because if you reduce it, then even the power on the variable will remain whole number. But if you reduce it, then it will be, if you write in the standard form or linear form, it will be power on the variable. This variable will become -1. That's why. Anyways, this is fourth one. Fifth one, x to the power 10 plus y cube plus t to the power, what is given? 50. Is it a polynomial? Of course it is a polynomial, but is it a polynomial in one variable? Of course not. It is a polynomial, but it is a polynomial in 3 variables, not one variable. Clear? Why it is a polynomial? Because power on the variables are all whole numbers. That's why it's a polynomial. And since there are 3 variables, that is x, y and t, so it is a polynomial in 3 variables. Cleared? So hope you have understood. Then second question, let us understand now. Write the coefficient of x square in each of the following. We have already learned coefficient and constant term in our previous class. So we need to write the coefficient of x square in this question now. Coefficient of x square in this question, yes. Question number 2. The first one is 2 plus x square plus x. What is the coefficient of x square? If you write it in standard form, then it will be 2 plus 1 into x square plus 1 into x. So what is the coefficient of x square? Coefficient of x square, excluding x square, what is there? 1. So what is the coefficient of x square? That is +1, positive 1. So coefficient of x square is, coefficient of x square is, coefficient of x square is 1, positive 1. Cleared? In the second one, 2 minus x square plus x cube. We are asked to write the coefficient of x square. So let us write its standard form. If we write the standard form, it will be 2 minus 1 into x square plus 1 into x cube. Our task is to write the coefficient of x square only. What is x? Where is x square? This is x square. What is its coefficient? -1. So coefficient of x square will be coefficient of x square is, here in this case it is -1. Do you get it? If there is negative sign, you have to assign, you have to put the negative sign. If there is positive sign, you need not to write the positive sign, because if you are not writing positive sign, then also it will be a positive sign. Clear? Then the next one is, third one is pi by 2 x square plus x. Look at what is the coefficient of x square here. Yes, this is x square. What is the coefficient? Pi by 2. So coefficient of x square will be coefficient of x square is pi by 2. Then number 4, root over 2 x minus 1. Is there x square? If there is no x square, can we imagine that there is 0 into x square? Can we imagine? Of course we can imagine, because 0 into anything is 0, meaningless. See, if there is no x square, then coefficient of x square will be 0. And even if you are writing the 0 x square, what is the coefficient of x square here? 0. So coefficient of x square is 0. If there is no x square, coefficient of the x square will be always 0. Coefficient of x square is 0. Is that okay? After that, the next one is you need to multiply this, okay? 2x minus 3, then x squared minus twice x plus 1. If you multiply it, then only you will get the coefficient. So let us multiply. 2 times x squared, that is 2x into x squared, 2x cube minus 6x squared plus 2x minus 3x squared plus 9x minus 3. So 2x squared minus 9x squared plus 2x 9x plus 11x minus 3. Look at what is the coefficient of x square. Coefficient of x square is minus 9. So you need to write, therefore coefficient of x square is minus 9. Hope you have understood up to here. Give one example of each of binomial of degree 35 and monomial of degree 100. The next question is, hope you will write the coefficient in this case. What is the coefficient of x square? That is minus 9. So write it, okay? Look at, if you understand the basic things, the polynomial part, polynomial, this exercise is very, very simple. So you are asked to go through the basic concept of polynomial, regarding polynomial again and again until you understand, okay? And if you have any query, any problem, you can message me so that I can make another video to make you understand. Or you can mail me also. Give one example of each of a binomial of degree 35. Binomial of degree 35. Binomial of degree 35. Binomials means two terms having degree 35. Is, suppose x to the power 35 plus x, or plus any number you can put here, plus 2 or plus 2 x you can write. Clear? So it is a binomial because there are two terms. What is the degree of this polynomial? This is 35. So binomial of degree 35. Clear? One example you need to write. Then one is monomial of degree 100. Monomial of degree 100. Monomial of degree 100. An example you were asked to write is, any example you can write, y to the power 100. See, it is not necessary that you will write y to the power 100 always. You can write z to the power 100, you can write a to the power 100, you can write p to the power 100, whatever you can write. Clear? So monomial of degree 100 we have written. After that, third question is done. Fourth question, look at, write the degree of each of the following polynomials. Degree you were asked to write in the following given polynomials. Roll that. Question number 4. And then question number 5 will be left. With this, we are going to finish this exercise 2.1. Question number 4, what is the question? Look at, write the degree of each of the following polynomials. Degree you are asked to write. 5x cube plus 4x square plus 7x. What is the degree? Yes, maximum. Degree means what? Maximum power. You have to keep in mind that the definitions you have to remember. That's why I told you that go again and again, go through again and again those basic concepts. If you have cleared your basic concept, you can answer fluently, very easily you can answer it. Otherwise, it will create problem. Again and again you have to go through them. That's why you are asked to go through, be cleared with the basic concepts of polynomials. What is the degree in this polynomial? What is the highest power on the variable in this polynomial? That is 3. So what is the degree? Yes, degree will be, degree is 3. Cleared? Second question, that is 4 minus y square. What is the highest power on the variable? On the variable, highest power is 2. So what is the degree then? Degree is 2. Then the third one is 5t minus root over 7. What is the highest power on the variable? That is 1. So what is the degree then? Degree is 1. And the last one is, what is the degree? Is it a polynomial? Yes, it is a polynomial. What type of polynomial is this? Constant polynomial. What is the degree of the constant polynomial? 0, I said. So degree of the constant polynomial is 0. So what is the degree? 0. Degree is 0. So hope you have understood up to here. Then question number 5, classify the following as a linear, quadratic and cubic polynomials. All right. X square plus x. What type of polynomial is this? Linear polynomial or quadratic polynomial? Yes, it is a quadratic polynomial. Why it is a quadratic polynomial? Because degree is 2, maximum power is 2. So it's a quadratic polynomial. So it's a quadratic polynomial. Is quadratic polynomial. Then the second one, x minus x cube. What is the type of the polynomial in this case? This is cubic polynomial. What type of polynomial is this? Cubic polynomial. Why it is a cubic polynomial? Because the degree is 3. Since degree is 3, it's a cubic polynomial, right? Cubic polynomial. Then third one, y minus y square plus 4. What type of polynomial is this? It's a quadratic polynomial. Clear? Why is it a quadratic polynomial? Because the highest power on the variable is 2. That's why it's a quadratic polynomial. Quadratic polynomial. Number 4 then, 1 plus x. It's a linear polynomial because highest power on the variable is 1. So you write linear polynomial is linear polynomial. Number 5, 3t. It's also a linear polynomial because power on the variable is, highest power on the variable is, there is no power means 1. So since the power is 1, it's a linear polynomial. This is also linear polynomial. You write is a linear polynomial. Clear? Then number 6, r square. What type of polynomial is this? Yes, it's a quadratic polynomial because the highest power on the variable is 2. So it's a quadratic polynomial. Then 7x cube. Since the highest power on the variable is 3, therefore it's a cubic polynomial. Cleared? So with this we have finished this exercise 2.1 of the chapter polynomial. So I hope you have understood. In our next class, we will try to solve more and more. We will try to understand more concepts on polynomials. So till then, you prepare the basic concepts, you learn the basic concepts and go through the exercise 2.1. You can answer all the questions, even though I have tried to solve many more from this exercise. Cleared?